Construction, right? So buildings being built, infrastructure projects being constructed, etc. Right? So it's a kind of an extension of BIM in design into the execution of the project. Does that make sense? We got to have more interaction than that. I mean, this has been a long day, so we need some interaction, right? All right, that makes sense. Okay, everybody here is familiar with BIM, Building Information Modeling. Yeah? Would you say unfortunately? That's good. Who here is not familiar with BIM? Okay. All right, cool. All right, well, I'll start and I'll define that here in a second. All right, so what we're going to talk about today is artificial intelligence. And the reason I talked about what my role is at Autodesk is I'm going to present this in the context of how artificial intelligence and machine learning, the future of making things, kind of how they manifest themselves on the design side of our software and the construction side of our software. Right now, there's other nuances of this. You heard Tom and Callan talk about it this morning in the keynote around manufacturing processes. Obviously, there's a lot of artificial intelligence and machine learning going on there with robots and some of the other really cool things. The skateboard that Callan rode out on. How many were in the keynote this morning? Okay. So, so there's a lot of cool stuff going on. We're going to talk about it more in the context of design, AEC, and construction. Does that work? Woo, it'll be a long thing. All right. Okay, so let's go ahead and get started, and we're going to have to make this a little more interactive as we go. Is everybody all right with that? Yeah? All right. Okay, and we're not advancing. This should kind of start moving. Is it not working? I'm clicking. It should animate. It should move. Well, imagine if you could. The slide was animated. The animation is not as important as what I'm going to explain. So for those of you who don't know what building information modeling is kind of, if you think about it, it's kind of our first foray into intelligence, right, or artificial intelligence. Because BIM, or building information modeling, is the use of a 3D model, right, but an intelligent 3D model. And then we use the data that is tied into that 3D model to make decisions on the project in design or construction or planning. We use it to analyze different data, so quantities, consumptions, things that go into the decision-making process that, most of you are familiar with. So if you think about, BIM's been around for, probably 15 years at least. And BIM is kind of our first, I think, venture into intelligence, right? So the model now had intelligence. Before that, we had 2D drawings, we had 3D models, but the 3D models were just graphics, right? So this was kind of our first kind of move in applying intelligence to the computer graphics to help with our decision making, like I said, to help with a lot of the different functionalities that we had in doing our job around these models. Does that make sense to everybody? Yeah? Okay, anybody still kind of not clear on that part of it? So I want to build off of that. Okay, all right, cool. Okay. There we go. So if you look up here, here's an extension of some of that intelligence out of the model, right? So we're able to look at, this is a project in the UK, but we're starting to look at analysis on that project, pulling data from it to make decisions. And this is just an example of some information on cost, schedule, quality, different things and different information that can be applied to the model, right? That's not just graphical data, but as data that, numbers, words, graphs, quantities, things like that we can start to apply in other aspects of the building process and design process. Okay? So I'm going to use the example here of BIM 360, but this obviously applies to manufacturing. It applies to the design side, but I'm going to apply it right now because the product that I manage right now is construction. I'm going to apply it here and talk a little bit about some of the ideas behind, machine learning and artificial intelligence. Right? So one thing is extensibility. So what I think makes the intelligence in artificial intelligence in the models valuable is that the data is extensible, right? Meaning that the data can now be leveraged outside of the software program and outside of the graphic constraints of the model. So now I can pull, let's say, quantities out of a model, and I can take those into cost estimating software, right? Because the quantities only being in the CAD model or the BIM model only gives me one level of value. But once I get those outside of that model, I can then apply them to other software applications. I can apply them to other workflows that I need to do to make that project successful and to execute on that project. I can also make them extensible to other people, right, so they can collaborate on that data. Okay? You with me? Yeah? All right. The other thing is concurrency. Right? Concurrency is important because how many folks in here are from the architecture, engineering, or construction industry? You got to raise them high, man. You'd be more proud than that. All right, that's pretty good. What about manufacturing? All right, where are the rest of you from? Come on, somebody tell me. Who didn't raise their hand for AEC? What industry are you in? Visuals. M&E? Visuals? Okay. You don't know? Huh? Yeah. Okay. Now, so, all right, for the folks that are in the from the AEC industry, this will resonate with you. Concurrency. What's important about concurrency is when we create this intelligence, and it's in the model, and we're able to extract it out of the model, the really important thing is that it's the right data. It's the most up-to-date data. It's concurrent data. Because one of the, I used to be an architect a long, long time ago, and I remember one of the challenges we had, and this was back kind of in the 2D world. It was CAD, but it was 2D. One of the challenges we had was that everybody tended to somehow end up working off of different data. Right? I was working off of a set of plans that I thought were the most current, but the engineer was working off a set that he thought was the most current. But the minute I made changes, they changed what he had, right? And so this concurrency challenge that we overcome is huge because you really need to be working on the same data, right? The most up-to-date data. If not, if you're working on out-of-date data, obviously you can spend hours working on that, and it's obsolete, right? Because you weren't working from the right information. Okay? So that's important. Interoperability, right? This is kind of tied into extensibility, but interoperability, another challenge that we have when we start, leveraging data out of these models is that, we get into issues with compatibilities. Right? We pull data out, and you try and take it into, another software application. Let's say we use the quantity example again. We pull the quantity information out, and we try and take it into our cost analysis application. It needs to be able to be read. There needs to be compatibility. Right? So this is another big one. And then controls. Right? Now that we have data, we need to put that under a lens or in a dashboard or in some sort of application that allows us to use that for controls on the project, be it a design project, a manufacturing project, or an execution, right? A construction execution of design data of a project or the manufacturing of something. We need to make that accessible and put it through kind of an instrumentation that allows you to manipulate it. Is everybody with me so far? Yeah? All right. Okay. All right. So the example I'm going to show you up here and kind of kick this off, and you guys all understand this is a round table, right? So at some point, I only got a couple slides left. We're going to start talking. And we're going to start answering questions and getting interaction and all that, right? Just, I want you to be prepared. So it's not abrupt after a couple of slides. All right? Okay, so, Project Insight is, in the construction space, in BIM 360, it's using this data, and it's our machine learning and artificial intelligence kind of application upon this data to start to make better decisions on your project, okay? And those decisions aren't just based on one particular project, but what we've done, and this is what Tom talked about this morning, we've started to gather data from all projects that have been done in BIM 360, okay? And issues that have come up inside of BIM 360 on those projects. And we've accumulated a database of about 20 million so far. So this is going to keep growing, right? And this is where machine learning comes into this, because not only now, if you're using this, are you limited to your company's information historically, or that project's information, but the machine learning here starts to analyze those 20 million issues and can start to come up with a way for you to predict what's going to happen on that job, right? And so the example we're talking about here in construction, that's one of the biggest risks in construction is not being able to predict things that happen. It costs a lot of money with rework when mistakes are made, right? And the ability to be able to predict or forecast where an issue might happen before it happens is really powerful. But this is only made available through machine learning, right, through the artificial intelligence, because now the machine can analyze these 20 million issues and can quickly, come up with trends, patterns, and other things to inform you as you're working on the project. If you think about it, previously in the construction industry, one of the most valuable things was experience, right? So a guy with 40 years experience was heavily valuable, because he had intelligence of 40 years. So do you think in those 40 years that this person worked on a job site, do you think that he'd come across 20 million issues and solve them? Probably not. So this is really powerful. The other powerful part of it is that it will continue to grow. As more customers start using this, the machine will continue to learn and will get better and better and more accurate. So a lot of the examples that we saw this morning, and Tom actually used this one as an example, but Callan talked about it as well. Okay, so let's walk through this a little bit. It's called Project IQ. And it's going to kind of walk you through kind of what's going on here. So you see there's a series of projects, and it starts to look at where the issues are, where the risks could come up, right? And then it's going to hone in on one project. And you can see, I know it goes kind of quick, but you can see where it starts to look at areas, concrete, waterproofing, other areas there, and it's extensible, right? It's available on a mobile device, a tablet, it's mobile. So everybody has it. They have the most current data. They're working from that, right? So this one's all about risk. And then when we look in here, we can start to see the things down the left side. What's really cool here is that it starts to analyze all these different projects from that one contractor, but also pull from that machine learning that it did on all the issues that have been put into the system, right? And then you get this dashboard, this lens, as I talked about a minute ago, that can help you make better decisions so you can start to look at and consume where these issues are. You can see at the top where it's looking at high, medium, low issues. It's got all the projects listed here. So you have multiple lenses you can look at. But this becomes really valuable. This particular one was 5 IQ models that were nested in this one view, right? So you can create customized views, that idea of project controls I talked about, of taking that machine learning data, that intelligence, but starting to put a different lens on it, right? So this is one lens in construction that we can look at that data through. All right? Translation's okay? Yeah? Okay. So, here's a quote from Layton Construction. So this tool is what they are building their future processes on around risk management, right? That's how valuable this is to them. They've bought into it. It's been in beta, right? But even in beta, it's got 20 million issues built into it already. But these guys are saying, you know what, this is the future of this because I can be much more predictable and control risk, cost, and different issues on the project by using this technology. All right, you're forewarned. We got one more slide, then we got to make it interactive. Okay, so at the end of the day, for those of you from the AEC industry, BIM was our first step into having intelligence, right? We put intelligence onto a graphical model, okay? We then took that intelligence in BIM and we started to extract it outside of the model for different design tasks, bringing in different software. We've now extended that, at least on the AEC side for Autodesk, into construction, where we're starting to use machine learning. Now we're starting to take that data and start to build a knowledge base around it that can be manipulated by customers, right? So real powerful stuff. So, all right, everybody take a breath, because now we're going to get interactive. All right. So, did this make sense? I know some of you aren't from the AEC industry, but the example makes sense to kind of frame the conversation up. I'm going to call on one of you. So watch your facial expressions. Somebody say something? What are you saying? You're saying something. You're thinking something. Oh, wait, you probably can't understand me because you're not translating. I think to do this, I'm going to need a translator to come down here because if we make this interactive, somebody has to translate for me. Can you help me? Come on out. We have a volunteer. Come on down. Okay. All right, we're going to pick somebody to get some interactivity going. What about, let's ask her.
Добрый день, представьте, пожалуйста.
Мария Болдырева, ФКТ инжиниринг.
Да, и что вы... Да. И что вы думаете по вот этому поводу, то, что он рассказал?
No. Again, speak in English. So, for me...
Oh, need me to repeat the question?
Yeah, so you were asking
No, yeah. So, for me,
Что вы думаете по поводу вот этой идеи?
you tell really smart ideas, but for me it looks like some future, really far future situation in Russia. Because now I'm chef structure designer, so I understand that I can learn my team to use BIM technology in my business. I can learn all my company to use BIM in business. Maybe I can learn some clients to use BIM in business, but then contractors, subcontractors, all this system to have some statistic data, big statistic data for use, something like that. And also I have clear understanding that risk in UK or maybe USA is really different with risks in Russia. So it's a very interesting and clear system, but when we can see it in reality.
What industry are you from and what is your role? Oh? What industry are you in and what is your role?
It's design company.
The architect?
No, I'm constructor.
Constructor.
I'm structural design.
Structural design. Okay, engineer. Okay, cool.
Can I have a seat now?
I'm sorry?
Can I have a seat now?
No. I think I may need you because she knew English, but I may need you.
Yeah, I'm joking,
it's okay.
right?
Thank you. No, yeah, don't do that.
Any help more? Oh yeah, we don't live in jungles. We have translator. You can have a seat. Давайте наушничек. При входе у кого?
If somebody can go grab me one of those, that'd be great.
She proposed, to grab the ear for you. I mean, the headphones. But nonetheless, I'll help you with just like.
Okay. All right. So I think what was interesting was I think the comment was this looks very futuristic, and I agree 100%. Right, because it does. Looks kind of like, I don't know, in Russia, did you have the cartoon called The Jetsons with the space people, a cartoon? Okay. In U.S., we did, right? So, but it was like futuristic, flying cars and things like this, right? So very futuristic. So you're right. And a few years ago, when Autodesk started talking about the future of making things across all the industries, right? Construction, architecture, engineering, design, manufacturing, M&E, media, entertainment. we started working through all of this, it was very futuristic, right? In fact, we pushed back I'm on the sales side at Autodesk because we thought from a customer standpoint, it was too futuristic. But we're getting closer. And I think as you look at, and you were 100% right, I think, for what most people feel about this, is it's a pretty far stretch. But as I went through that, I think you can all agree, though, that it's like you can almost touch it now, right? Like you may think that, I don't know if it works for my customers, but it's not that far-fetched because I can see how it could work, and I see that people are probably using it, right? But I think so now we've gone, I think, to the point of it kind of being this futuristic thing, a few years ago, to now it may not be for every customer or everyone's business, but I think everyone can agree that it's more realistic now. Right? I mean, I think what I went through, you probably say, you know what, it's analyzed 20 million things. It's a machine. It's a computer. It's extensible. It's cloud-based. It can do that. It's got infinite computing capabilities. Yeah, I can see it doing that. But, I don't know if, to your point, if the information in there is going to be particular to business that I do in Russia, for example, right? Because, Jeff, you showed an example of the UK, right? And business is different. So I think we've come, though, the last couple of years with computing and cloud and stuff, we've kind of moved in the right direction. But now I think we are at the point where each business needs to look at this machine learning and artificial intelligence in their own way and figure out what does it mean to them, right? All right, so I think they're going to try and put some sort of apparatus on me so this works better. Hang on a second. All right, so what do I do now? Somebody talking to me?
Can you hear me? 1, 2, 3.
All right, so I got a lot of stuff going on here. I got microphones and machines and... All right, so that was good. That was the first kind of, I think, level of interactivity that we've had, so that was really good. This is really weird because I can hear myself, but that was really good. All right, so let me go a little further. Who in here is not from the AEC industry? Who here is from manufacturing? Does anybody in here work in the manufacturing space? No? Nobody? That's pretty wild. Okay. Anybody here in the media entertainment space? Right? Hollywood, special effects, TV? Okay. All right. So, okay. We got to figure one thing out. Okay. Only half of you raised your hand when I said, are you in the architecture, engineering, construction space? But now nobody's in a space different than that. So is anybody in a space different than architecture, engineering, and construction? You are. What space are you in?
IT specialist.
Okay, you're an IT specialist. But so do you work for a company though that's in one of these industries?
For oil and gas company and building oil and gas infrastructure.
Yeah, you can talk in Russian. She can translate for me if you want to, so if it's easier. No, I got that. So what she's saying is she works for a company. She's in the IT department for a company, but that company does oil and gas, right? So they're responsible for oil and gas. So from an Autodesk perspective, right, they fall into infrastructure, plant design, right, designing plants and things like that, right? So she's in a different space. So let me ask you though, from your perspective, especially because you're in IT, this must make sense to you, right? This kind of artificial intelligence, machine learning, I think, you probably have a really good grasp of that and say, yeah, this makes perfect sense, right?
Yes, indeed. This makes perfect sense, and it is interesting, but it's not clear yet at which phases of the life cycle of a given site or object can we apply machine learning and artificial intelligence. Will it make sense at the design level or at the engineering research level, or will it make sense only at the time of construction and assembly and installation? I think there was another question here. Could you give some specific examples of how we can use your tools based on your experience? For example, how could you predict and prevent violations or accidents in construction, for instance? How can I identify some hidden, some latent defects? with the use of your functionality.
Okay. There's a little.
И еще, наверное, вопрос такой.
Also, a question, one more. So big data and machine learning, for this to work, it takes a lot of information, a lot of data. And we need to take similar sites or similar industries to accumulate data from. So do you have this statistical data? Do you have this history? Because in Russia, everything is in Excel spreadsheets and PDF, so it's hard to analyze this type of information, this type of format.
So there's a couple questions there. So two things. So first one is an example on the safety side. So I think that's a really good one. And so here's what we're doing right now to help with that and to start this kind of automation and kind of bring safety into, I think, predictability and some of the different aspects of machine learning. We made an investment in a company that does recognition of photography and videos. Okay, now what's unique about this is that we're seeing on the safety side that it can recognize safety vests, right? So people who are working on a construction site or in the oil and gas on a drill or a rig or something like that, they wear a vest and a helmet. Well, the software can shoot video, or this application takes video that's being shot at the job site, and it can recognize first who the safety people are, if the people working on the job site are properly outfitted, right? Are they wearing their vest? Are they wearing a helmet? Harnesses, so high-rise in construction, it can recognize from being able to interpolate the photos. Are they wearing a harness? Is the harness set up correctly? Is the scaffolding set up correctly? So they can really start to analyze without having to have a person on the job site doing this. The photos and videos can be analyzed in real time to be able to predict where there could be issues at, right? If harnesses are not being attached properly, if scaffolding is not being built properly, if people are not wearing hard hats, if they're not wearing safety goggles. And the other thing it can do is if we put RFID chips in the safety vests, we can start to look at how people are moving about on the site, right? We can look at, is there traffic patterns that are causing risk, with equipment, cranes and other things. We can start to look at how are people actually abiding by the safety rules. So, by looking at different, I think, technologies, in this case, video and photography recognition, we can apply that in construction for safety and start to build up kind of this intelligence and really be able to use this to manage against risk, manage where and predict where we may have issues and make modifications to the job site or to the employees or to the equipment to be able to shore those off before they happen. Does that make sense? And then you had a second question. So the second question was, so you repeat the second question real quick?
So the second question was about this know-how, so that for the big data to start working, to be used, machine learning to start up and running. So we need a big sampling of data, huge data. I understand that you were talking about mainly about safety of construction works, but probably there are some other cases of the application. So at least at the design stages, before the physical construction, video surveillance, and so on, there is probably huge data that can be analyzed and used for kind of prediction at the design stage before you construct. So, do you have any accumulated experience in your practices of such cases that could be used, or each company will make this in-house database and for further use? And can use it only in a year or 2 or 3 down the road?
Okay, so the question is, okay, Jeff, you talked about an example that happens during the construction of a project, but what about before, I think there was a couple questions there. So one was, what about what happens before construction? And I think the other one was about the data itself. So let me tackle the first one. So, when I talked about building information modeling in this case, and I talked about that intelligence, I talked about kind of this move from just graphical 3D data, right? And before that it was 2D, but let's say, we'll skip ahead to the 90s where we had graphical 3D data, but it was just graphical, right? We did it for renderings and visualization, things like that. Well, we went to this point where we had intelligence, and we could apply some intelligence to that. So if we think about things that happen before construction starts, right, of how we can leverage artificial intelligence or machine learning, one of the things is optimizing design. And I think it was shown this morning, but this idea that you can put a program into the software. And a program in the architectural, I think in construction world, is basically an owner says, I want an office building, I want it to be this big, and I want it to have these kind of parameters built around it, right? There's no design of it yet. There may not even be a site, right? But he has an idea of what he wants to do and a budget and things like that. One of the things that machine learning can do is by analyzing all the designs that have been done and all the parameters that are that the owner or someone wants to put on the project, they can go through thousands of iterations very quickly of the optimal design of that. And they showed the example, it's kind of like the example shown this morning of that chair that Tom showed, that the 25-year-old student who'd never designed anything or manufactured anything before basically went through a computer algorithm and told it that she wanted to design and build a chair that was the most optimized for a certain weight and the size of a chair, right? Same thing in design for buildings is you put parameters in and then it can go through many, many iterations to come up with the most efficient. So I think that's one huge, huge benefit, because anybody who has designed anything in manufacturing or in construction, architecture, engineering knows that, optimization is very hard to get. You're limited by time and basically manpower of people being able to figure it out. So this is huge for us. I think the other thing that can happen around that is optimization of scheduling and other things that go into kind of the execution of the project and really how money is spent, how much time it's going to take to build it. So this idea of iterations and optimization is pretty big, right? And doesn't just happen during construction, but in the AEC industry, that machine learning can be applied really at any phase of where a decision needed to be made on the project. You can.
I have a question about the general idea. How does the Autodesk checks the ground or picks up the direction to develop its software? I mean, AI and big data is a very vast domain. So how do you pick up the niche, and how do you analyze what will be lucrative and where to go? If it makes sense. I mean, how do you analyze, what will be flourishing and how it can work?
You mean where do we put our efforts to develop software? Like where? Okay, that's a good question. Okay, so I think along the same lines, the question is where do we focus as a company, Autodesk, on where we invest?
No, where? How do you pick up the right niche? Not where, but how? How do you think? It's about how do you pick up how we make the choice that you will develop big data or AI. So what will be the next trend? How do you?
Oh, okay, I got you. So the question is, how do we make decisions on where we invest, where we put our efforts at? Is that right? Is that fair? Okay. So I think, like any company, and I don't know that this ties in as much to us leveraging big data to do this, but we make our decisions based on trends that are happening in adjacent markets. So I guess we do analysis and we do optimization on that analysis to figure out where we should invest, right? What's happening in, for example, the construction industry is highly, highly influenced by manufacturing, right? Manufacturing is a constrained system. It's usually an assembly line, so things tend to get more automated there, happen faster. But you see right now, those of you that are in the AEC space, that a lot of the learnings that have happened there over the last 20 years with technology are starting to be applied to the construction and design industry. Prefabrication, for example, prefabricating things in a factory, versus bringing them on site for tolerances and accuracy and things like that. So I think what we do, and I think we do a pretty good job as a technology company, is we look at adjacent markets and trends, and we start to make investments in that way based on things that we see. I think that we try very hard to listen to customers. This will be kind of the sales pitch, but we try very hard to listen to customers and I think figure out how we can help our customers, do better, and then the design side, make a better world, right? That's kind of our big tagline right now, is make a better world. So we're really trying to help engineers, architects, manufacturers, media entertainment, visual artists. We're trying to help them, make an impact and kind of, I think was said this morning, but impact change, but in a positive way, not a disruptive way. And I think it's pretty big for the company right now. Let me tie that to big data, because I think that's more applicable to kind of the session we're in. So big data, I think is like kind of a catch term, but really what it is for us is it's this ability of infinite computing power, right, which is being brought on by the cloud. So it's the ability to apply, hundreds or thousands of computer machines to solve a problem. And, examples we can have is, these really beautiful 3D renderings that happen either in movies for special effects or happen, as static, models of architectural buildings and things like that that look real. There was a time when those took days for a computer to render. Because of cloud computing and infinite, power, we've been able to get those done in minutes and sometimes seconds. So we're talking about going from the processing power of a time frame that took days or weeks down to minutes and seconds, which is huge because what it allows us to do is, again, make decisions faster with this information and not have to wait and not be constrained by the processing power. So it's kind of uncoupled us from being limited based on the time that it takes to perform, the computations. Question? Oh, you don't? You just took the microphone? All right. Question? He's got a question.
По-русски. Я правильно...
So correct me if I'm wrong. So BIM 360 that you're talking about, so it first accumulates the data and then the artificial intellect will process this accumulated data for better decisions. Is that right?
Yeah. So the question is that, an example that I gave around this product of BIM 360 on the data side is it's accumulating a lot of data, and then we're applying the machine learning to, process that data and really take that data and compare it and perform analysis on it. So you're 100% right. That's the value, right? The value is kind of twofold. One is it's able to kind of gather data, the kind of the big data part of what we just talked about. So we're able to kind of gather and store all this data. But then the real value comes from the machine learning, right, or the artificial intelligence of them being able to analyze and kind of manipulate that data in a very, very efficient manner. And then, being able to use it in many different ways, right? So you can then figure out what lens do you want to look at that data, what decision do you want to make from that data. So that's really the big, powerful difference in that.
У меня такой вопрос.
So I have a question again about this system that finds the risks and helps us to mitigate them, to avoid, points out the highest risks. If we imagine a construction site where we have a sufficient number of cameras so that no worker would wear no protection uniform, so how much will the system cost? Will it be cheaper just to have the safety security engineer that will just watch these people and control them than a number of cameras? That's my first question. So comparing the costs of the system and the person, and so can for some project we can forbid the system to use the data for our use. For instance, some are classified construction site and we have no right to share this information about those. So can we use this system and continue the system for testing of our project and without providing our data for the further machine learning? can we keep our data to ourselves?
Okay. So again, so you guys have a lot of two-part questions. So two parts. So the first part is, I think, is more of a cost-benefit analysis. And the example was having cameras on site. So the question is, you know, if we put these cameras on site to analyze safety issues, to look for people wearing vests, helmets, harnesses, scaffolding, to really look to be able to predict, you know, accidents before they occur, is that more cost-effective than having a person do that? And, you know, I think that is where I think each business needs to make that assessment, each project needs to make that assessment. The only thing I'll say is that I think the input has been that having people do that tends to be more expensive because of the cost of a person on a job site. And a person on a job site's got two eyes. You know, I think for the cost of one person, you could have multiple cameras, multiple angles. I think that it works much better. The other thing I would say is, in the construction space, we do have one sense of a lot of history on safety, and that's that, you know, really, we've come a long way, I think, leading up to this point with job sites getting safer, but it's been done through regulation. But there's still a lot of, if you walk on a job site, you can still find a lot of challenges that are out there. So I think that more thorough are the cameras, and I actually think the cameras are cheaper. I mean, people are expensive. I mean, at least for the most part, most places, people are pretty expensive. And they're limited, right? Because the other thing that's cool is that people look at things subjectively, cameras don't, right? So the second question was, I think it was about privacy. I think it was about, if you have this data, it was about sharing that data. Do you want it shared? Do you not want it shared? How do you control that? So I think that's a good question. I think whenever we get into the conversation about big data, I think that comes up, right? The idea of security, about privacy, about who's getting access to this data. And right now there's a lot of regulations. Different governments have their own regulations. There's a lot of things happening right now to define how that data is stored, how it's manipulated, how it's shared, who has access to it, and things like that. I will say that our space and this question is not, we're not the only industry, only company. You're not the only company kind of grappling with this, right? This is a big issue for a lot of the technology companies you work with, right? In the U.S., it would be your cable provider, right? So you have television, and how are you getting access to that? They have your billing data, they have information. It's digital, it's on their website. You can access that. Is it secure? Telecom is the same thing, right? Telecommunications, mobile phones, that type of data, your banking data. So there's a lot of things, I think, that are driving that conversation, and I think it's being worked through. But it's being worked through, I think, more at a regulatory standpoint of governments, and each country kind of looks at it differently. And we've applied, so on the BIM 360 side, there are some areas of regulation that we become compliant with from a security standpoint to store that data. A lot of it has to do with privacy. A lot of it has to do with the data that is being stored. Is it being shared? Where is it being shared? And things like that. And so these government regulations that are put together, we then have to become compliant with them. So, in the European Union, they've come up with a set of requirements that we've become compliant with. In the U.S., we have a set that we've become compliant with. Russia has a set as well that, for us to do business, we obviously have to be compliant with, things like that. So it's a hard question to answer because it's a bigger question and we're only one part of it. Does that make sense? Yeah.
Just on that, so again, I'll go with the two-part question. Why not? I take it when you look at the data, so the record data, the 20 million issues, it's the characteristics of that issues, not the actual issue itself. So you're not going to be digging around in someone else's data. So you're not going to say, oh, this happened in this region on that site then. It's the characteristic of that issue that you're storing. Cool, that's that one. I always have a cultural interest around people and this. So if we're, at the moment, a lot of people trade on staying in a job because of their knowledge. So a lot of people trade on that. So when you go to then look at, if you're then transferring knowledge and insight to a system, are we going to now have to behave, do you think, that we're going to have to behave more like the millennials now who don't anticipate being in a job for more than 2 years? So therefore you're not trading on that longevity?
I'll take the second one. I don't think the first one was a question. I think it was good. It was a good clarification. Thank you. The second one's interesting. I think if you think about one of the things that we used to say about what we were doing with building information modeling data and what we were doing, even a few years ago, kind of our tagline for BIM 360 was that we were democratizing data, right? We were making data extensible to people in the field for the construction project. They were sharing the same data, right? This idea of democratization of data. And I think, your point about, one of the values that I think people, especially in the construction industry, used to bring to the table was experience. And really what I talked about of these issues that we analyzed and were able to provide machine learning around, that is what it was, right? The reason the person with 20 years experience or 40 years experience was valuable was because he had seen more than the guy with 2 years experience, right? So he'd seen problems, he'd seen solutions. He had a database in his head of a way to solve a problem. So yeah, I mean, in a way, this democratizes value, from a worker standpoint to a certain degree. I don't think that you're asking me the question of, do I think it's going to influence, employability, kind of where the industry goes? I mean, I think in some degree it will. I don't know that it'll be negative, and I don't really know what the outcome of it will be, right? Because I think there's probably things right now that we can't automate, and so the person with 40 years experience still is probably more valuable than the guy with 2 years experience, although the guy with 2 years experience is probably more energetic, But yeah, but I think there will be changes. I think it'll be a bit of a democratization. I don't think that person with 40 years experience can just market himself as having 4 years experience. I think he'll have to have unique perspectives on things, which I think is better for the industry, right?
Можно вопрос? У меня вопрос по...
A question. My question is about the quadrocopters and how they can be used by Autodesk. I thought Autodesk was going to use it. So as part of this artificial intelligence conversation, could you speak more about how you may use those quadrocopters, so small devices that will fly hover over a construction site and keep track of what is going on at the construction site? And do you think the data they generate could be integrated into the artificial intelligence effort? So what is the potential here? And don't you think this approach may become a global oversight on behalf of the customer on a construction site?
Okay, so I got that. So I think it's about drones and about, I think you used the word quadcopters, but I'll use drones, right? So basically flying devices around job sites. So yeah, so I think this is a huge, huge value. And I think the thing I talked about a second ago of, being able to manipulate and interpolate and identify things in video and photographs, I think pulls right into this, right? So being able to use a drone to fly over a job site, I think gives you a perspective that you used to not be able to get on projects, especially if there were no higher structures next to them. You couldn't go above and look down. So I think in a very cost-effective manner, drones enable us to do that. And the value in the drone is having a video device or a camera take pictures or video so that you can start to look at that. And again, the machine learning and artificial intelligence that we're applying to that is the acquisition we made that does recognition of different things and objects in those photos and in that video, right? So instead of having to have people look at it and say, that's an issue, there's a danger here, there's a safety issue here, and all these things, this machine can now do that. It can start to recognize things that are going on. I think the other thing that the drone and these flying these cost-effective flying devices do is being able to do laser scanning, spatial manipulation, right? Starting to look at terrain and model terrains of very unique job sites, where I think before this would have been a very manual process. I think we're seeing now where surveyors and other companies are using these drones to very effectively, with a couple of people on the job site where they may have needed 2 or 3 times that many people to map things out before, they can use this technology to get a higher perspective and to more quickly kind of analyze things. And then if you think about that data, that mapping data that it's gathering, point data, that's, artificial intelligence, machine learning that's manipulating that data, to create mesh maps and topo maps and things like that are where it makes it valuable. I can remember, I think maybe 10 years ago when looking at, we called them COGO points, right? So kind of some of this early scanning, it was just a series of points, and it was really kind of hard to understand when you were looking at the screen what you were looking at. But now we can do meshes in real time and other things like that that make it much more effective. Good.
So the question is, how do you think, how much information we should collect to avoid some statistic mistakes in the system like that? For example, I successfully finished maybe around 50 projects in my career. All my company finished maybe around 2,000 projects in career of company, but we still couldn't stop to making mistakes. So how much information we should to collect?
So I don't know that I have that answer. So I guess the answer is, how much data is enough data to make good decisions? And I don't have an answer for that. I think that's a very relative question. I think the more data you have, the better informed you are to make the decision. But I think what you're speaking to, I think, in excuse me, even better, is that idea of the example I gave, right? So if you think about you're one person and you've got kind of this database of information of what you understand. Maybe your company has, a level of 100 above that. Well, the example I gave you was probably 1,000 above that, 1,000,000 above that, right? Because it was data from outside sources that kind of were building up this statistical information to make decisions. So I don't know what the right amount of data is. I'm assuming it plateaus probably at some point. But that's where kind of this idea of cloud computing and the infinite ability to run algorithms comes into play. Because you're not limited to only being able, I guess you are limited in some level, but that limit's pretty high now with infinite computing capability to be able to manipulate all that data, right? So I think before probably the challenge was kind of making sense. If you had a lot of data, it was hard to make sense of all of it. I think the other thing cloud does, it helps us with computing all that data and trying to categorize it, analyze it, and make it, like I talked about before, these different lenses that you can start to look at the information through. That answer it?
It's not so much a question, just as a comics, it just came to me when you're talking about cameras versus human beings, because we've deployed that technology. It's the fact that human beings don't have zoom, don't have thermal, can't see in the dark.
Yeah, it's a great point, right? So the question was more of a comment on, I think, the idea of the human eyes versus having cameras. And I think, again, Rob, a great point, right, is that the human is very subjective, right, which I talked about. But even I think more importantly, the example that he just gave was they're limited to how far they can see. Can they see in the dark? Is the sun shining and reflecting and all these things? And the camera can do other things, right? It can see infrared, it can see heat, it can see things where if the light's not good enough, it's dusk and work's being done early in the morning, or it's a limited lighted area inside the building. The camera can see that. The camera can see where you can see, it could see heat through walls. The person can't see that, right? The person could be obstructed, and the camera can see. So that's a great point. Thank you. Anybody else? All right, well, we're right. I think we got like 1 more minute left. So I want to thank everybody, and hopefully this was enlightening to you. Thanks for getting interactive. I know these are hard to do, especially in the afternoon, and we started off, I think, with the slide deck, which helped. But thanks a lot for those of you that answer questions. And hopefully for the rest of you, you got a lot out of it. All right, thank you.